Hello, in this video we're going to discuss an example for an alpha emission. We have discussed in the previous video that the decay of a thorium isotope emits an alpha particle to form a radium isotope. And according to the laws of conservation of charge and mass number during radioactive decay, we're going to understand this equation. So, the charge number of thorium is represented by the numbers along the bottom, so it's equal to 90. This is the charge before the change, and it represents the total number of protons. According to the laws of conservation of charge, then 90 should be equal to the charge number of radium added to the charge number of the alpha particle. Let's check if this law is verified in this radioactive decay. The charge number of radium is equal to 88 and the charge number of the alpha particle is 2. So 88 plus 2 gives an answer of 90. So we can say that the law of conservation of charge number is confirmed in this decay. According to the second law, which is the law of conservation of the mass numbers, the mass numbers, which represent the total number of protons and the neutrons for the thorium isotope, is equal to 228. Let's check if they are equal to the total number of neutrons and protons after the change for the radium and alpha particle. So for the radium and the alpha particles, the mass number is equal to 224 for the radium added to 4 for the alpha particle. This gives an answer of 228. So the mass numbers before the change is equal to the mass number after the change. This confirms that the law of conservation of mass number is confirmed in this decay.